Moving along, the next set of problems that we're going to have to solve for x in are going to be problems that have more than one x. You're going to have multiple x's. All right, specifically, you're going to have an x on each side of the equal sign. That's what this means. Variable on both sides of the equation. The equation is split in half by the equal sign, so you're going to have an x on the left-hand side of the equal sign and an x on the right-hand side of the equal sign, and you're going to have to figure out what x is. So before we do that, let me show you when you have two x's that are on the same side of the equal sign. So say you have 3x plus 2x equals 25. All right, you're not going to divide by 3 to the other side and divide by 2 to the other side. That's going to be messy, and it'll actually give you the wrong answer. What you're going to do, and you may remember this terminology, is called combine like terms. Combine like terms. So when you combine like terms, when you're trying to solve for x, you only do that if they're on the same side of the equal sign. So you have 3x and you have 2x, they're on the same side of the equation. They're on the left-hand side, so you can combine those together and say that's 5x. So you have 5x equals 25. Now you solve this by just dividing 5 to the other side. X equals 5. All right, pretty simple. I think you guys probably know how to combine like terms because you're smart. You wouldn't be in algebra if you weren't smart. And you've already done combine like terms. It's not super difficult. When it gets a little more difficult is when they're on opposite sides of the equal sign. So let's do that same problem, just mix it up a little bit. Let's say 3x equals 25 plus 2x. So it's almost the exact same thing as we just did, but the one we just did had 2x over here with the 3x. Now the 2x is on the right-hand side with the 25. So now you can't combine these the same way that we did last time. You can't, on your second line, say 5x equals 25. That's not going to work. Because if you did do that, then x would equal 5, and if you plugged in a 5 to check your work, you would say 3 times 5 is 15. You would say 2 times 5 is 10, and you would get 15 is equal to 25 plus 10. 15 is equal to 35 is not true, therefore the mystery number is not 5. So if you can't combine those, how are you supposed to solve this? Well, there's a way, because technically you can combine these, but you have to do the inverse operation like we were doing yesterday when we were solving for x. You got to move one of these x terms to the other side so that they're both on the same side. And when you do that, you have to change the sign, because remember, we're working backwards. When we're trying to solve for x and we move a number or a term across the equal sign to the other side of the problem, we have to think backwards. We have to do the opposite. So I'm going to move the 2x because it's smaller. We're adding 2x. I'm going to move the 2x over here, and now I'm going to subtract it because we do the opposite when we move it across the equal sign. So it's 3x minus 2x, and that's just a single 1x, which we read as x. So now x is equal to 25. And that's our answer that we got. But let's check that, because that's not very intuitive. That's hard to imagine in your mind. So when you can't see it in your head and you know for sure that it's right or wrong, you should plug that back into your problem, especially on a test. This is the nice thing about algebra, is you can almost always check your work in algebra to know if you're right or wrong before you pick that final choice on your test. So we came up with x is equal to 25. So let's check and see if that's right. 3 times 25 is equal to 25 plus 2 times 25. So whatever we figure x is, we substitute that number back in for every x that we have in the problem. 3 times 25 is 75. 25 plus 2 times 25 is 50. And sure enough, 25 plus 50 is 75. We get 75 equals 75. That's true. That means we solved it correctly. The answer to that problem is, in fact, x equals 25. So that's how you solve for x when you have an x on each side of the equal sign. Now, when I started this problem, I subtracted 2x to the other side. The reason I did that is to keep my problem positive. You don't have to do it that way. You could subtract 3x to the other side, and it's just going to make this problem more complicated, but I'm going to show you how it still works. So let's move 3x over here. Well, if I move 3x over here, what's left on the left-hand side of the equation? Nothing. Everything's gone. The only thing that was over there was one term. It was a 3x, and I moved it to the right. So there's nothing left over there. So all we have on the left-hand side of this problem now is a 0. We have everything on the right-hand side. We have our 25, and we have our 2x and our 3x. What do we do with that 3x? We subtract it, because whenever we move something across the equal sign, we're working backwards. We're doing the opposite. This was a plus 3x, and now it's a minus 3x. What's 2 minus 3? Negative 1. So this is a minus 1x, which is just minus x. You don't ever need the 1 as a coefficient. If there's no coefficient in front of a variable, it's a 1. So 25 minus what equals 0? Well, 25 minus 25 equals 0. So it's still going to work. We know we got to put a 25 in for x, and we'll get 0 equals 0. But if we don't know that in our head, how do you go about solving this? Well, you got to get x by itself. So you got to move 25 to the other side. So you move 25 to the other side, and what are we going to do with that 25? We're going to subtract it. Now, this is a little bit tricky because this looks like a subtraction problem. We're supposed to do the opposite. So the opposite of subtracting is adding. So a lot of people want to add there. But this subtraction sign always goes with the term that's after it. So this minus sign goes with the x. So we're looking at the sign that's in front of the 25, and there isn't one. So that means it's positive. It's a positive 25. So we got to move it over here and make it a minus. We got to do the opposite. So 0 minus 25 is negative 25. Negative 25 equals negative x. So that might seem like you're done, and you might pick negative 25 as your answer, and you're going to get it wrong. Because we're not trying to solve for negative x, we're trying to solve for positive x. So if you end up with a negative x as your answer, you got to change the sign on both sides. Make that x positive, change this sign too, so that 25 becomes positive. And you end up with x equals 25. So you end up with the same answer, but you see how much more difficult that one was? It's always more difficult to move the bigger x term. You always want to move the smaller x term. All right, you move the smaller x term, and boom, you're right to your answer, x equals 25. Way easier, a one-step equation. You move the bigger one, you just added a lot of work for yourself. A lot more chances to make a mistake. So try and get in that habit. When you have to combine x's and they're on opposite sides of the equal sign, move the smaller one. That's the best advice I can give you in solving these problems. Here's one that might trick people. Say you have negative 2x equals 40 plus 6x. All right. Which one is actually smaller here? Well, that's probably not a good example. Let me try this one. Negative 6x plus 40 equals 2x. Okay. I just told you, you always want to move the smaller x when you're combining them and they're on opposite sides of the equal sign. So people at a quick glance will say, okay, 2 is smaller than 6. But when you take your time and look a little closer, the 6 is negative. A negative number is always smaller than a positive number. So the negative 6x is your smaller one. That's the one that you want to move. So you move 6x to the other side, and since it was the sign in front of the 6x of that term, the sign in front of that term, that's a negative term. That's a negative term, a negative 6x, so we got to make it positive. So 40 is equal to 8x. What do we multiply 8 by to equal 40? We multiply 8 times 5. 40 divided by 8 is 5. So 5 equals x. All right, if you looked at this and you thought, all right, Mr. V said always move the smaller x, 2 is smaller than 6, let's move the 2. So you move the 2 over, it was a positive 2, so now you make it a negative. So now you have negative 8x plus 40 is equal to what? It's equal to nothing, because we moved all our terms. We got rid of all our terms, so there's nothing left over there. Now we're not really any closer to our answer. This is going to have to move the 40 over there. We get negative x is equal to negative 40. So you divide by a negative 8, and x is equal to negative 40 divided by negative 8. The negative divided by a negative is a positive. So you still end up with x equals 5. I'm not saying you can't do it that way. It's just more steps. You're dealing with negative numbers. There's more opportunities to make mistakes. That's the thing with a multiple choice problem, is that one mistake ruins your whole problem. There's no partial credit. So why add a bunch of steps? You're just adding more opportunities for you to make a mistake. So try and keep it as simple as possible, which means move the smaller number. So don't forget that the negative number is always smaller than the positive number. Even though 6 looks bigger than 2, it's negative. Move that negative number.